Alright, good morning everyone. This is Miss Strangle. This is our 11-4 video, three-dimensional figures. And some people might really like this section, especially if you're kind of artistic visual. Some people it's not their favorite. It's a little bit different than some of the other sections that we do. But it's good. It kind of exercises the visual part of your brain, which for me is challenging, but is also good. Gives me a chance to grow. Alright, so our essential question, what are 3D figures and their properties? How can we represent 3D figures? So our learning target, we're on 11D. I can identify, name, and draw 3D figures and their nets. So in terms of vocabulary, our first vocabulary is a polyhedron. So and a polyhedron, let me first write the definition for that. All sides. So a polyhedron is a 3D figure where all sides are polygons. So all the faces and bases are polygons, so there are no circles. So something like a sphere or a cylinder would not be a polyhedron. And what are the parts of a polyhedron? So the edges, maybe I'll make it blue so you can see the edges. These are edges. These types of things are edges. I'm going to erase that. The vertices, just like, on a angle or a triangle or a polygon, the vertex or vertices are where your edges meet. And the faces are basically the side or surface. All right, so what is a polyhedron or what is a polyhedra? So we have types of solids. Basically, we can break these into two main categories. Category 1 is a polyhedra, and the plural has the N, polyhedron, polyhedra. Okay, and we have those that are not. So just to remind you here, all sides are polygons. So the two main types of polyhedrons are prisms and pyramids. So we'll talk about specific properties of prisms and pyramids. And then just to kind of give you a sense of what is not a polyhedron, a cone, a cylinder, and a sphere, because some of those faces and surfaces are not polygons, they are circular or round. All right, so I'm going to make kind of a table for prism, or you can make a Venn diagram, but I just think with writing, for me with my stylus, I'm going to do a table. But I'm sort of making a Venn diagram here. So what are some properties of a prism? What are some properties of a pyramid? And what are some common properties that they both share? And I think sometimes people think a prism and a pyramid is so straightforward, but I do see a lot of students get them confused. So the key properties of a prism, the faces are rectangles. The faces are rectangles. Okay, for a pyramid, the faces are triangles. And a lot of times then people think the sides, when we say faces, the sides are rectangles and the sides are triangles, but you could flip the orientation of your prism or pyramid, so it's not really super helpful to think of it as sides. All right, the other key property of a prism is that there are two bases. So I'm going to draw a couple of prisms over here. So you could have a triangular prism. It's kind of like a Toblerone bar, if you will. That is a common triangular prism. So it's a triangular prism because you have two bases that are triangles, but the faces are rectangular. So that is one example of a prism that also includes triangles. Another prism could be a pentagonal prism, something like this. So you would have two pentagonal bases. You'd have one over here and one over here. So you'd have two bases, and the sides, see, I did it right there. The faces would be rectangles. So those are your key properties of a prism. How can you tell if something is a prism? It will have two bases, and the faces will be rectangles. That is a prism. A pyramid, the faces are triangles, and there is one base and one vertex. And I'll draw a few. So you could have a square or rectangular pyramid. Not the best drawing, but it would have one base. And then the sides or faces, the faces would be triangles. I could have a pentagonal pyramid, something like this, where again there would be one base. This is the base, and the faces would be triangles, and there's that vertex at the top. So it's not really about just triangles versus squares. I think counting the number of bases is probably the most helpful way. Then what do they have in common for both? Well, they're obviously both 3D figures, three-dimensional figures. They are both polyhedron. There are no circles on these. They both have faces, edges, vertices. And the other thing I'm going to put a star is they both are named after the shape of the base. And we'll kind of go through that in some of the examples, but if you think about this shape right up here, how do we name that? That is a triangular prism. So we name it because the base is a triangle, we name it triangular prism. Down here, this would be a pentagonal prism. So we name it after the shape of the base. Same thing for a pyramid. We would name this a square or rectangular pyramid. So we name it because the pyramid, the base is a square. This would be a pentagonal pyramid. So the naming system is kind of the same for both. So I'll zoom out. If you need any more time for that, feel free. Otherwise, we will move on. Okay, so if we were in class, I actually have all these, I have actual manipulatives or figures or shapes that I would give groups to do, and we do kind of an investigation or exploration, and people would count the number of vertices, edges, and faces. I think we will still do this, so it should still kind of be in your notes, but we will modify a little bit. So we are just going to do the first 3 shapes. So you would just need these 3. So you can kind of make that table, and you would only need these 3 figures. So we can cross these out if you want, and these out if you want. So I will do the tetrahedron kind of to help you. So the vertices, if I think about the vertices, let's see, I see 1, 2, 3, 4 vertices. So I'm going to put that in my table. The edges, I have 1, 2, 3, 4, 5, 6 edges. And that's getting a little messy, so I'm going to erase that. The faces, we have that bottom triangle right here. And then we have 3 triangles kind of on the side. 1, 2, and then there's 1 over here. This is also 1. So that means there are 4 faces. So if you can pause the video and see if you can fill out the cube and the octahedron for a second. See if you can do that. I'll put up the answer in a second. So you should be getting 8, 12, and 6, 6, 12, and 8. Then what we're going to try to come up with is called Euler's formula. So we're looking to see, is there some kind of pattern between the vertices, edges, and faces? So I would maybe zoom in on the vertices column. And the faces column. So if we add the vertices and the faces, do we see a pattern? So let's think. If I look at the let's highlight it here. If I look at the tetrahedron, the vertices 4 plus the faces 4 is 8. If I look at the cube, 8 plus 6 is 14. The octahedron, 6 plus 8 is also 14. So is there any kind of pattern that you can see? Hopefully you noticed 4 plus 4 is 8. That would be the edges. Oops. The edges plus 2. So 4 plus 4 is 8. How else can I get 8? 6 plus 2. 8 plus 6 is 14. How else can I get 14? 12 plus 2. So this is kind of the formula that we would spend a little more time if we were in person in class, solving and discovering and whatnot. But that is where that formula comes from. All right, so we're going to use that formula, Euler's formula, to find the number of faces, vertices, and edges of the polyhedron and check. So right here and here, so this was the formula that we kind of wrote out before. And if you look, here's a good question to see if you're understanding. This is a pentagonal pyramid. We would name it after the base, which is a pentagon, and the sides are triangles, so it's a pyramid. So it has 6 faces. The bottom base is a pentagon, and then there are 5 triangles. So that's 6 faces. It has 6 vertices and 10. If we plug that into our formula, yes, that does work. Because this is not an example. This is just sort of showing you it's kind of a vocabulary of showing you how Euler's formula